Now we will discuss ideal sources and practical sources. So the voltage or the current sources that we have been discussing till now, they are ideal sources. Okay, so what is meant by ideal? First, if you consider a voltage source, this is represented how? If you take a DC voltage source, this is going to be represented like this, right? Now, irrespective of the current through it, in any condition, that is, it is going to give you a voltage, a particular voltage Vs. So this is called ideal source. Okay. But in practicality, what is going to happen? Ideal means it will not exist in real life. In real life, how it is going to be? It is going to have a resistance in series with the voltage source. Okay. So that means now this entire combination, this is the voltage source. So when you keep a voltage source, it means that there is a ideal voltage source in series with a resistance. Okay. So now what is the effect of this resistance? If this we take as Vs, it has to give Vs voltage. But if a current I is flowing, then what will be the voltage delivered? This is the actual voltage delivered by the voltage source. So what will this be? Vt is equal to Vs minus I into Rs. So you can see that this is dependent on the current through it. Okay. Now you have to understand the difference between a practical source and a dependent source. Okay. So here you might think that since the voltage is dependent on the current, then it is a dependent source. So dependent and practical sources are one and the same. That is not the case here. You have to clearly understand that practical source, it specifically means the presence of some resistance. That means the instrument is not perfect. Whereas a dependent source is different. What is it? If you take a dependent source like this, some resistance is here. Let us say the voltage across this is V0. Then the voltage delivered by the dependent source is going to be 4 times of this voltage. Okay, so this is how the dependent source is different from the practical source. By definition, it might mean the same thing, but in actuality, they are very different. Okay, so this is a practical source. Now for the dependent source only, if you take this dependent source, this is ideal dependent source. Okay. Now if this voltage source has some internal resistance associated with it, then we call it as a practical dependent source. Okay. So I hope now that this is more clear to you. Now this resistance what we have in series with this voltage source, ideal voltage source, we call it as source resistance or internal resistance. Okay. Ideally, what would we expect? We would want Rs to be 0. Okay. Ideally, Rs is equal to 0, but practically Rs, it is very small. Okay. So this is for a voltage source, Rs will be very small, and if it becomes 0, then that is the ideal case. So you can see that when it is becoming 0, when this resistance becomes 0, then it will be the same as this ideal source, right? So that is why for a voltage source, the practical source will become ideal if the source resistance becomes 0. Now, often it is represented by a graphical method. Okay, so the current is taken here, and this is the terminal voltage, that is the voltage delivered by the source. If it is an ideal source, then Vt is going to be constant at Vs. And if it is a practical source, as current increases, the voltage will drop. Okay, so this is for ideal source and this is for practical source. Okay, so this line is nothing but Vt is equal to Vs minus Irs. Okay, so this line is nothing but Vt is equal to Vs minus Irs. Next, if you see a current source. So what will be an ideal current source? It will deliver a constant current irrespective of the voltage across it. It is always delivering the current Is. Okay, so this is ideal. What about practical? So for a practical current source, the resistance is going to be in parallel. We are going to represent it in parallel. Remember that it's not like there's an instrument and then in parallel to it there is a resistor. We just represent a practical source like this. Okay, the behavior will be similar to the behavior of this combination. That is important here. Okay, so if this is Is, then what will be the actual current that is delivered? So we can take this as load current. So if this is Rs and the voltage we can take as some V, okay, then IL will be equal to Is minus V by Rs. What is V by Rs? It is the current through this resistor. Okay, so there will be some current that is flowing through this, and the actual current that is delivered will be this current minus this current. So this is the practical source. You can see that the current is now dependent on the voltage across the instrument. Okay, so this entire combination is what we call as the practical source. Now what is the ideal case here? The ideal case is going to be when the source resistance or the internal resistance becomes infinity. Okay, so this is the ideal case. Practically, Rs is going to be very large. Okay, so you can see the difference between voltage and current source. In voltage source, internal resistance was very small and ideally it is 0. For a current source, the internal resistance is very large and ideally it should be infinite. Then what about the graphical representation? So you can once again, so here I will take the x-axis as voltage and this as current. Okay, so then what will be the, for an ideal case, the current delivered is going to be constant at Is, and for a practical case, the current will keep falling as voltage keeps increasing. So this is for the practical source.